Our planet has always been formed by rivers, but what if we could also shape them? These large-scale projects are much more than just channels. They're meant to supply water to dry farmlands, prevent floods from damaging cities, and even build exhilarating play areas for whitewater rafters. Some of them are gigantic and have the capacity to deflect large floodwater surges. Others are more complex and exact, directing water to particular crops or supplying energy for hydroelectric power plants. Constructed rivers demonstrate how creative engineering may alter how nature functions. The idea of artificial rivers is not new. Although water has long been used by civilizations to create canals for agriculture, transit, and flood control, the enormity and ambition of modern artificial rivers distinguish them from earlier examples. These are enormous technical undertakings that sometimes even outperform the laws of nature. They are not just ordinary irrigation ditches. Imagine a river that just arises. That is how some artificial rivers actually work. They are supplied by intricate pumping systems, reservoirs, or even natural rivers that already exist. The building process is an engineering marvel. First, the river's course needs to be carefully planned. Massive earth-moving equipment creates channels in the ground that the water may follow. For artificial rivers to regulate water flow, careful engineering is required. To control the pace and direction of rivers, engineers construct locks, dams, and diversion canals. In order to stop erosion and preserve the river's distinct shape, the banks of the river also need to be fortified, frequently with concrete or other materials. An artificial river's design is determined by its intended use. Flood control channels can withstand extremely large water surges, since they are frequently deep and wide. It is possible for irrigation canals to be more elaborately branched and smaller in order to provide exact watering levels to certain fields. Join us as we discover some of the major artificial rivers around the world. The Kachi Canal Project, Pakistan. The Kachi Canal Project is a 499 kilometers long canal project situated in the Baluchistan and Punjab provinces of Pakistan. It starts from Tapa barrage at Indus River and terminates in Baluchistan. The canal provides sustainable irrigation water supply to 72,000 acres of agricultural land in Baluchistan and 30,000 acres of land in Punjab. The cost of the project, after its revision, is now Rs 80.5 billion. The water infrastructure and irrigated agriculture in Baluchistan will sizably increase when Kachi Canal Project will be completed. The project was started in 2002 and was almost abandoned due to cost and time overruns. The project is being done in 3 phases. Phase 1 comprises 6 sections totaling 399 kilometers, 305 kilometers Punjab, 94 Baluchistan. Phase 1 is almost complete with just Kachi 6A and 6B still in progress. Phase 2 comprises one section of 60 kilometers in Baluchistan, which is not started. Phase 3 comprises one section of 40 kilometers in Baluchistan, which is also not started. Total system length after completion of all phased will be 499 km, 399 km plus 60 km plus 40 km. Baluchistan would get 194 km, and Punjab will get 304 km of canal. The 399-kilometer-long main canal, out of which 351 kilometers is lined, takes off from Tapa barrage in Muzaffargarh district of Punjab province and ends at Deraputi district in Baluchistan province. The discharge capacity of the main canal is 6,000 cusecs. As many as 914 structures have been constructed at or over the main canal, including head and cross regulators, road and railways bridges, cross drainage and escape structures, and watercourse crossings, etc. The length of main canal is 399 kilometers, of which 305 kilometers lies in Punjab region, whilst 94 kilometers are in Baluchistan. The Kachi Canal project is divided into 3 phases. The project was inaugurated in October 2002 at Tapa barrage. Several revised deadlines for completion of the project have been given in past, but the project is not yet completed and work is ongoing at slow pace. Phase I, Part A and B, was completed in August 2017 and inaugurated on September 14, 2017 by then Prime Minister Mr. Shahid Khaqan. When completed, 72,000 acres of virgin land will be irrigated. Great Man-Made River of Libya. The Great Man-Made River is a network of pipes that supplies fresh water obtained from the Nubian sandstone aquifer system fossil aquifer across Libya. It is the world's largest irrigation project. The project utilizes a pipeline system that pumps water from the Nubian sandstone aquifer system from southern Libya to cities in the populous Libyan northern Mediterranean coast, including Tripoli and Benghazi. The water covers a distance of up to 1,600 kilometers and provides 70% of all freshwater used in Libya. According to its website, it is the largest underground network of pipes, approximately 2,820 kilometers, and aqueducts in the world. It consists of more than 1,300 wells, most more than 500 meters deep, and supplies 6,500,000 cubic meters of fresh water per day to the cities of Tripoli, Benghazi, Sirte, and elsewhere. The late Libyan leader Muammar Gaddafi described it as the eighth wonder of the world. The Great Man-Made River Project, GNRP, was conceived in the late 1960s, and work on the project began in 1984. The project's construction was divided into 5 phases. The first phase required 85 million m3 of excavation and was inaugurated on 28 August 1991. The second phase, dubbed First Water to Tripoli, was inaugurated on 1 September 1996. Afghanistan's Qosh Tapa Canal. The Qosh Tapa Canal, also called the Qosh Tapa Canal, is a canal being built in northern Afghanistan to divert water from the Amu Darya. The main canal is expected to be 285 kilometers long, and the overall initiative seeks to convert 550,000 hectares of desert into farmland. The Qosh Tepe Canal begins in Balkh province and is expected to end in Faryab while passing through Jowzjan. The Taliban-run government of Afghanistan has made the canal a priority project, and the construction begun in early 2022. Images supplied by Planet Labs showed that from April 2022 to February 2023, more than 100 kilometers of the canal had been excavated. The first phase of the project was completed in October 2023, with the second phase immediately commencing. Independent experts and engineers have expressed skepticism and concern about the project, stating that the Afghan government does not possess the know-how to effectively complete the canal. In particular, they have noted that there is a lack of oversight with rudimentary construction methods being employed. In December 2023, it was reported that the canal had experienced a major breach, with satellite images showing a large body of water forming near the place where the embankment had collapsed. Environmental experts have raised concern that the Qosh Tepe Canal will make the Aral Sea situation worse by diverting even more water from Amu River. A detailed analysis of the project by the independent CBR.ASIA analytical publication found that construction methods employed appeared rudimentary and concluded the likelihood of water losses in the canal was high. China's South to North Water Diversion Project. The South-North Water Transfer Project, also translated as the South to North Water Diversion Project, is a multi-decade infrastructure megaproject in China that ultimately aims to each year channel 44.8 billion cubic meters, 1.58 x 1012 cuft of fresh water from the flood-prone Yangtze River Basin in southern China to the more arid and industrialized northern China. This is to be performed through 3 canal systems: the eastern route through the course of the historical Grand Canal, the central route from the upper reaches of Han River, a tributary of Yangtze River, via the Grand Aqueduct to Beijing and Tianjin, the western route, which goes from 3 tributaries of Yangtze River near the Bangkal Mountain to the upper streams of the Yellow River, through provinces like Qinghai, Gansu, Shaanxi, Inner Mongolia, and Ningxia. Mao Zedong discussed the idea for a mass engineering project as an answer to China's water problems as early as 1952. He reportedly said, "There's plenty of water in the south, not much water in the north. If at all it's possible, borrowing some water would be good." Construction began in 2003. In 2008, construction costs for the eastern and central routes was estimated to be 254.6 billion yuan, $37.44 billion. The government had budgeted only 53.87 billion yuan, $7.9 billion, less than a quarter of the total cost at that time. This included 26 billion from the central government and special accounts, 8 billion from local governments, and almost 20 billion in loans. As of 2008, around 30 billion yuan had been spent on the construction of the eastern, 5.66 billion yuan, and central routes, 24.82 billion yuan. Costs of the projects have increased significantly. By 2014, more than $79 billion had been spent, making it one of the most ambitious and expensive engineering projects in human history. The project required resettling at least 330,000 people in central China. Critics have warned the water diversion will cause environmental damage, and some villagers said officials had forced them to sign agreements to relocate. In the summer of 2013, complaints arrived from the fish farmers on the Dongping Lake on the project's eastern route in Shandong, reporting that the polluted Yangtze River water entering the lake was killing their fish. Scientists have been concerned that the project will increase water evaporation losses. The exact amount of evaporation loss is not known, but it may be improved in the future as more water is transferred and the flow rate increases. New Delta Project of Egypt. Egypt's government started digging a 174-kilometer artificial river in 2023 in its western desert to irrigate New Delta, its largest ever agriculture project, which aims to reclaim and cultivate 2.2 million fenans, nearly a quarter of Egypt's current agricultural land. The project includes about 688,000 fenans. The study area on the previous map, south of the Tapa axis and west of the Old Delta, in addition to the Mostakba Mazer project, which is built on an area of 500,000 fenans. In the same context, the project includes about 250,000 fenans related to the national service projects. The reclamation of one fenan costs about £200,000. The government has also been constructing 30 water lifting stations and a mega tertiary wastewater treatment project, Al Hammam plant, to guarantee a sustainable water source. The plant can treat 7.5 million cubic meters of agricultural wastewater per day, which, according to Water Resources and Irrigation Minister Hani Sulam, is the world's largest agricultural drainage project, and its water is enough to cover a large part of the New Delta project. The project aims to accommodate the increase in population inside the Delta area, especially from young graduates, and to compensate for the loss of agricultural lands due to unjust construction. It was scheduled to finish within 10 years, but President Abdel Fattah al-Sisi directed that should be completed within 2 years from 2021. The implementation of all phases was merged into one phase. The New Delta is a huge achievement which aims to strengthen the state's strategy in agricultural and urban expansion, achieving food security, and establishing new agricultural, urban, and industrial societies. The location of the project is unique and is close to the Old Delta, with a strong road network and close to ports, which supports the agricultural exportation to global markets. The New Delta plant has been awarded 4 significant GR titles. The largest water treatment facility, spanning a massive size of 320,600 square meters. The largest water treatment plant with a capacity of 86.8 cubic meters per second. The largest epoxy coating in a building, covering an expansive area of 520,339 square meters. The largest sludge treatment plant, showcasing a substantial capacity of 670.01 kilograms. If you enjoyed this video, please like, share, and subscribe as we look forward to seeing you in the next video.